Hi everyone, so today we're going to be looking at straight lines. We're going to be talking about equations of straight lines today, looking at how we can draw them, how we find their gradients and their y-intercepts, and also learning how to manipulate the equations, because there are 3 forms of equation that you need to know for A-level. So where is this on the syllabus if you're interested? This here is the specification for AQA, and the one down here is for Edexcel. So if you're on the AQA exam board, the stuff we're covering today is under topic C1, and we're literally just doing the first sentence here on the equations of a line. And if you're on Edexcel, then this is topic 3.1, and we're just doing this first bit here. So let's get on to the basics now. Most of this should be a recap of stuff you know from GCSE. So these are our axes. We've got this, which is the y-axis, you can remember because the y is quite long. And then this one is the x-axis, the horizontal one. This point here where they cross is either called the origin or the center, and that has coordinates 0, 0. Just as a reminder for coordinates, this one is the x value, how far along, and this one is the y value, how far up or down. You're probably already familiar with this form of a straight line equation, which is y equals mx plus c. That's the one that we use standardly at GCSE, and it's really good because we've got this m value here and this c value here, which can tell us information just at a quick glance about the line we're drawing. The m value is the gradient, which is the slope of the line or how steep the line is, and the c value is what we call the y-intercept, which is where our line is going to cross on the y-axis. So let's have a look at this. The y-intercept here is 1 because we've got our line passing through 1 on the y-axis. As a coordinate, that would be 0, 1, and we're looking at the second half because we're looking for the y coordinate. You can either have a positive or a negative gradient depending on the direction. This one here is positive, and if the line is going in this direction, then it's negative. Let's take a look at these lines here, starting with the pink one. It goes along 1 square, up 1, along 1, up 1, along 1, up 1. So our gradient here, or the letter m we call it, is 1. For the yellow now, let's count. Along 1, up a half, along 1, up a half, along 1, up a half. So our gradient for this yellow line is a half. Now let's look at this blue line. Now this is going in the other direction. This is going in the negative direction. So our gradient is going to be a negative number. But let's count. So we're going along 1, down 2, along 1, down 2. So because we're going down, it's going to be a minus number, but m is minus 2. Negative 2, because we're going in that direction. So that's a quick recap of the gradient. If we go back to the original line that I drew and just have a quick look without the squares because it's not drawn to scale, we can see that the gradient is 1, because when we go from -1 to 0 on the x-axis, so going along 1, we're also going up 1 from 0 to 1. Our gradient is 1, and our y-intercept, as we already found earlier, is also 1. So if we wanted to write the equation of that line, it would be y equals m, 1x, so 1x, we just write x, plus c, which is also 1. Y equals x plus 1. That is the equation of that line. Now at A-level there are 3 forms of straight line equation that you're required to know. The first one we've just gone through is the y equals mx plus c one, which you should already be familiar with, where the m is the gradient and the c is the y-intercept, where the line crosses the y-axis. The benefit of this form of the equation is that it's easy to find the gradient or the y-intercept, because you can easily just pull them out of the equation. There's no rearranging needing to do. You can just look at it. There's the m, there's the c. So if you're asked to find m or c, the gradient or the y-intercept, this is the form of the equation you want to use. The next form you're required to know is this one. It's y minus y1 equals m times x minus x1. Now here again we've got the m being the gradient, and this x1 and y1 are actually coordinates of any point on the line. They can be absolutely any point on the line, and they're the coordinates for them. The reason we use this form is because it's useful if you're given a point on the line. You can easily find the equation just given a point, and also either another point or the gradient. You can easily plug that information into this equation and you get the equation of the line that you're looking for. The final form of equation we use at A-level is ax plus by plus a constant. It says c in all the notes, but we're going to call it d just because we've already got a c up there. That's all equal to 0. So this is just a constant number. It doesn't matter what letter you call it. It's just a number not multiplied by an x or a y. Now this is good because it's the most general form of a straight line equation. so it's quite useful to apply to lots of different things. And you can also, by looking at this, find horizontal or vertical lines, because if a equals 0, we lose that term completely and we just end up with a term in y, and that ends up with a horizontal line. And similarly, if b equals 0, we lose this term completely and we end up with an equation just in terms of x. That translates to a vertical line. Just to show you what I mean by that, let's say, take the case that b equals 0. That means ax plus d equals 0, which means x equals minus d over a. Now d and a are both just numbers, they're both constants, which means that minus d over a is also just a number, a constant, which means that whatever value of y we have, our x value is always going to be this same number. So let's just say, for this example, that minus d over a is here. It could be anywhere depending on what the values of d and a are, but whatever value of y we've got, our x value is going to be that same value minus d over a, which means our line is going straight down there. Excuse my slightly wonky drawing, and we end up with a vertical line. And if you want to, you can apply the same thing for the horizontal line case. If you set a equals 0, you'll be able to see why that is the case. So those are the three forms of equation that you need to know for A level. It's very easy to rearrange from one to the other, and it's very useful to be able to do that as well. So that's a very good thing to practice, and we're going to practice a little bit of that now. So let's do some example questions. I've just written the three forms of equations up here, so we've got them easy to access if we need them. So the first question, find the equation of the line with the gradient minus 1 passing through 1 minus 1. Give your answer in the form y equals mx plus c. We've been given the gradient, that's very useful to us. We've also been given a point on the line. If you remember, this second form of equation, this one here, is very useful if we've been given a point on the line, because that x1, y1 is a coordinate value of any point on the line. So our x1 and y1 are 1 and minus 1. And we've also been given the gradient here, straight out of the question, m equals minus 1. So let's plug all those values into our equation. Y minus y1, here that's minus 1, so minus minus 1 is plus 1, equals m minus 1 times x minus x1, 1. But we're being asked to give it in this form, y equals mx plus c, so we need to rearrange it so that y is on one side and everything else is on the other. And we end up with y equals minus x. So there's actually no y-intercept here that we've been given, because it's actually y equals minus x plus 0. It crosses at the origin, and we've been asked to give it in the form y equals mx plus c. You don't necessarily need to write that, but what I would say is that it's always good to write the value of m and c, because you're making sure then that it's definitely in the form that they asked you to. So our value for m is minus 1, our value for c is 0. Next question is finding the gradient of a line. It says find the gradient of the line 2x minus 5y equals 4. Now let's look at our three forms of equation again and decide which is the best one to start with. I think looking at this top equation here, y equals mx plus c, is the best one, because as I said before, you can just easily pull out that m value. So let's rearrange this into the form y equals mx plus c. We want all the y's on one side and everything else on the other. We end up with 5y equals 2x minus 4. Y equals 2 over 5x minus 4 over 5. Don't get put off by the fractions, the maths itself is exactly the same. The m value is the value in front of the x, which is 2 over 5, and there's your answer. The final question is asking us to draw a line. Now it says sketch the line 6y minus 4 equals 3x plus 1. The first thing I'd say to you if you're asked to draw a sketch is to make sure that your axes are labelled y and x. So rearranging, we have 6y equals 3x plus 7. Y equals a half x plus 7 over 6. So let's mark 7 over 6 on our axes, because that is where it's going to be crossing the y-axis. That's our y-intercept, our c value. And because the gradients are half, we know the incline's going to be quite shallow. So I'd say maybe something like that. Now it doesn't have to be completely accurate, because it has just asked you to sketch the graph, but it is important to work out what this value is. The y value is 0 here, because it's on the x-axis. It's not far up or far down, it's just 0. We need to find the x value. And the way we can do this is simply plugging it into the equation. So you end up with 0 equals a half x plus 7 over 6. X equals minus 7 over 3. So that's the x value of that point, minus 7 over 3. So just to recap, we've got three equations. We've got y equals mx plus c, which you're probably already familiar with, where we've got the m and the c value for gradient and y-intercept. Then we've got the y minus y1 equals m times x minus x1. Here it's important to remember that the x1 and y1 are coordinates of a point on the line. Finally, we've got ax plus by plus a constant equals 0. That's the more general form of the line. It's going to come in quite useful later on when we look at points of intersection. But for now, it's just important that you can rearrange from one to the other and you're comfortable with what all the different letters mean. So that's it for today's video. Thank you very much for watching. Next time we're going to be going into more detail about gradients. I'll see you then.